Hey everyone, welcome back. Today we're going to be talking about projectile motion. One of the most important things about projectile motion is breaking all of our vectors into x and y components. So projectile motion is a type of free fall. So our only acceleration is gravity. Since gravity is just an idea in the y, there is no acceleration in the x direction. This means that our velocity in the x doesn't change, but our y velocity gets slowly eaten away, becomes zero, and then grows. So again, here we can see that our velocity at an angle of theta gets launched, and we can see something that I like to call the Vegas rule of physics. We know that what happens in Vegas stays in Vegas, right? So what happens in the x stays in the x, what happens in the y stays in the y. Since acceleration is only in the y, our velocity in the x stays the same the entire trip. And in the y direction, this is a pop-up. This is an initial velocity in the y that is thrown upwards, becomes zero at the maximum height like we see here, and then falls back down. So again, projectile motion, velocity 2, which is the x direction here, remains constant, while velocity 1, which is in the y direction, is accelerated downwards. So acceleration is completely independent of the direction of motion. Doesn't matter whether my velocity is straight up, straight down, anywhere in between. My acceleration in this situation is always straight down. It's completely independent of my velocity. When we use our normal coordinate axes, then acceleration in the x again is 0, and acceleration in the y is gravity. And we can write this in vector form, where this is saying that it's 0 in the x direction and g in the y direction. These are unit vectors, they just tell us what direction. So some tips while we're doing our 2D problems. We treat x and y independent. What happens in the x stays in the x. What happens in the y stays in the y. But we can link them together with things like time. We use x to solve for time and y to solve for whatever we're looking for, or vice versa. Vegas rule of physics, they're independent. We always want to start our problems by breaking up each vector into x and y components. And then once we do that, we can break our equations into x and y components and use those versions of our equations. So that just means that our two-dimensional problem is only two one-dimensional problems. I solve x first, then I solve y. Or I solve y first, then I solve x. I just do two problems for one dimension, and that makes it two-dimensional problems. This should look familiar. It's just three of our kinematic equations in vector form, and we break them into their x components up here and y components down here. Our fourth kinematic equation we normally only use in component form anyway, so we don't have to worry about the vector form of that. It's just already broken into its components. Now, projectile motion, we're going to look at a ball projected upwards with an initial velocity and an angle theta above the horizontal axis. Our acceleration vector, again, gravity is just an idea in the y, so our acceleration in the x will be 0, and our acceleration in the y will be negative g, going downwards. So our acceleration vector is negative g y hat. It's negative g in the y direction. Our velocity in the x is just the magnitude of our initial velocity times cosine theta. Again, this should all look familiar. And we have the exact same thing with our velocity in the y, except it's sine instead of cosine. Now that we have our vectors in their x and y components, we can set up our equations. Here's one of our kinematic equations in vector form. I want to break that up into its x form. So we just have all of these vectors, x components, plugged into this equation. We're starting at the origin, so my x initial is 0, and we know that my acceleration in the x is 0, so these two terms die off. They don't survive. We multiply by 0 and add 0, and we know that velocity in the x is just vi cosine theta, so we multiply that by t. And we get the same thing in the y. We're still starting at the origin, so this initial y is 0, but we have an acceleration in the y, so this term survives. And we get a negative 1/2 gt squared added to vi sine theta t. That's one equation. If we need another equation, it's right there. We split this one up into its x parts too. And again, acceleration in the x is 0, so we just get vi cosine theta, which if we look up here, we will recognize as our initial velocity in the x. A 2D problem is just two 1D problems, while in the x direction, it's just constant velocity. Our final velocity is equal to our initial velocity. We can also split this equation up into its y components, and again, the acceleration term survives, and we get vi sine theta minus gt. So that is how we split our equations up into x and y components. We have to treat them separately because what happens in one stays in that one. So we have one-dimensional equations right here. We solve, and then we have a second 1D problem, because when we treat things differently, because Vegas rule of physics says so, we end up with two one-dimensional problems that combine into one two-dimensional problem.